Hello students, I Dr. Suhita Chatterjee, Assistant Professor, Department of Economics from the Graduate School College for Women, Jamshedpur, welcome you all to my third session on an introduction to testing of hypothesis. In the earlier session, we had talked about the alpha and beta related to which is helpful for understanding the level of significance. Here, we would be discussing the ways to test a hypothesis, where we would be discussing the two ways. First is p-value and another is critical value. In short, there are basic two ways to test a hypothesis, that is p-value and based on critical value. Now, what is this p-value? P-value is the calculated probability of making type 1 error. Now, before this session, we had a discussion that probability of type 1 error was related to alpha, the value of alpha. Here, we are talking about calculated probability. Mark this term. P value is the calculated probability of making type 1 error. And its relevance lies, it gives researchers a measure of strength of evidence against the null hypothesis. It is a measure. We calculate the p-value of test statistics of a given sample distribution, and then we compare it with the value of alpha. If p-value is less than equal to alpha, we reject H0 when it is true. That is, we get statistically significant results. Whereas, if p-value is greater than alpha, calculated, if p-value is greater than alpha, we reject null hypothesis. It means we accept all alternative hypothesis. So, the smaller the p-value, stronger the evidence of rejecting the null hypothesis when it is true. Now, let us see these figures. Here, the yellow region that you are seeing is the region of rejection, that is, defining the probability of committing alpha error. And beyond that is the green line is denoting the p-value. If the p-values lie beyond the alpha value, here we are seeing one-tailed test. So from one side we are seeing the distribution, and if the p-value lies beyond the yellow region, we say that it is coming in the region of acceptance, the region of accepting null hypothesis, because the yellow shaded region defines the region of rejection. Whereas if the p-value, that is based on any test statistics, what we take z statistics, t-test, chi-square, if that test statistics, the p-value calculated on that basis lies within that yellow region, you can see. So in that case, if the p-value is less than alpha, we reject the null hypothesis when it is true. In the upper figure, we had seen that the p-value is greater than alpha. So we fail to reject null hypothesis. It means we accept the null hypothesis. Whereas in the second case, we are rejecting the null hypothesis since the p-value is in the critical region and is less than alpha. In case of left tail and two tail, we are defining both in the case of one tail test and two tail tests. So one tail tests are of two types, that is left tail and right tail. Here you can see that the alpha that is denoted on the right hand side, it is showing the rejection of H0, the red mark, and on the left tail, if we are saying on the left hand side, the alpha region is showing the region of rejection. two-tails test, here the alpha, if I am taking 5% level, that is alpha is equal to 0.05, then both sides 0.025 is the region that is being marked. That for that reason it is alpha by 2. It means we are taking half the region, alpha by 2. If it is 0.05, if it is 0.025 on right hand side, 0.025 on the left hand side, and if the p value falls in these two regions, then we will reject H naught when it is true. Otherwise, if it comes in between the two regions, then we would accept the null hypothesis. So, p value is necessary for constructing a test of significance. It also defines the size of the critical region. It is desirable that the test procedure be framed which minimize the both types of error. But this is not possible because for a given sample size, an attempt to reduce one type of error invites or is generally accompanied by an increase in the other type of error. The test of significance, therefore, can be designed so as to limit the probability of type 1 error alpha to a specific value that we take usually 5% or 1%, that is alpha equal to 0.05 or 0.01, and at the same time to minimize the probability of type 2 error, that is beta. Then coming to an example, suppose if a p-value is 0.0263, what does it mean? It means that there is 2.63% chance that your results could be random. That is happened by chance. By chance it has happened that you have got that result. It is quite less. If the p-value is 0.92, this means that the results have 92% of being completely random and not due to anything in your experiment or survey. Therefore, smaller p-value will give more significant results. Smaller the p-value, more significant are the results. Now, coming to the second one. What is the critical value? It is a point or points on the scale. Point in case of one-tail test and points when we talk about the two-tail test, because it is on the two sides of the distribution. On the scale of the test statistic beyond which we reject null hypothesis and is derived from the level of significance of alpha of the test. So we can see the significance of alpha. It is important both in case of p-value, for comparing p-value, as well for defining the critical value. So it is the line. What is critical value? Critical value is the line that separates the rejection region from the acceptance region. Size of a critical region is usually less than or equal to the level of significance, that is alpha. However, for a continuous population or a continuous distribution, the critical region is equal to continuous population distribution. The critical region is equal to the level of significance that we call alpha. Now here you just see the orange area is defining the alpha region, and the critical point, you just see a point, and if I draw a line, so there it just demarcation, that is a demarcation, that divides the rejection region from the acceptance region. The rejection region, as you can see in the left, in the one tail test, that is left tail test, here the alpha is 0.05 and it is the shaded region is the rejection, whereas the critical value is the line, the perpendicular line that you are saying that shows the value. If the value comes in the critical region, in the rejection region, then we reject the null hypothesis when it is true, and if it comes in the white region, beyond the shaded region on the other side, then we accept the null hypothesis. Here we have, let us look on the critical region, the shaded region. In case of one tail test, that is, the upper one is showing the left tail test and the lower one is showing the right tail test, whereas the two tail critical region are also being showed. That is, the alpha, the value of alpha is divided into 2, that is alpha by 2 on the both sides. Now, summarizing the steps in the test of significance, because in the process of learning, for understanding the test of significance, we have got an understanding what is alpha, what is beta, what is type 1 error, type 2 error, what is p-value, what is critical value, what is critical region, and now summarizing all those things, how can they be helpful for drawing the conclusion for which we are waiting for. Let us see. First, we have started that set up a null and an alternative hypothesis. Second, what is the state, the appropriate test statistics, and also its sampling distribution. Now, when I am talking about the test statistic, for this, the sample is analyzed to decide whether to reject or not to reject the null hypothesis. For this purpose, we choose a suitable statistic called test statistic and find its sampling distribution, assuming that H0 is really true. In large sample test, the statistic Z, which approximately follows the standard normal distribution, is often used. In small sample test, the population is assumed to be normal and various test statistics are used which follow standard normal, chi-square, T and F distribution exactly. Third is select the level of significance of the test, whether to have 0.05, alpha equal to 0.05 or 0.01. Then find the critical region of the test at the chosen level of significance and compute the value of test statistic on the basis of sample data. And ultimately, we draw the conclusion if the computed test statistic lies in the critical region. That is, if the p-value lies in the critical region, it means that the rejection region, then we reject H0. Otherwise, if it lies in the acceptance region, we do not reject H0. That is null hypothesis. Hope you are clear with the small key concept related to the hypothesis testing. These are the references that I have followed and referred to, and thank you for your kind attention.